recording. Hello, good man. Minutullah, Moisegwa, Joseph. Okay, welcome to PLD 38. You can see that here just few people. I think everyone busy with the portfolio project, final project, but it's fine. We can keep going. Then they can watch recording. So today we have three LeetCode. Three LeetCode, account merge, spiral, and subset. So account merge was something we need to do yesterday, but we didn't do it yesterday, so gonna do it tomorrow, hopefully. So let's start from subsets, because I think we dealt with this problem before in different contexts, so it can be familiar. So let's just take the problem to Excalibur and read it. Read this there better. Okay. Then hello, Mega. Okay, let's try to understand what is this problem trying to say. Okay, so given an integer array nums of a unique element, return all possible subset, the power set. The solution set must not contain duplicate subset. Return the solution in any order. So I guess if we see here, we can see that they give us array nums 1, 2, 3. So it's return an empty array and then 1, 2, 1, 2, 3, 1, 3, 2, 3, 1, 2, 3. So it's like we return all the subsets without duplicates. Order doesn't matter, and the num is gonna be always unique. And if they give us 0, it's gonna be like empty array 0. Okay, now the numbers can be also negative numbers. I don't think that matters that much for this problem, and they're gonna be unique. Okay, who have question about the problem? Is everyone like understand the problem? Then okay, let's see what could be possible solution for this, or we can deal with this. What you think? You can like open mic talk or like write in chat. Backtracking. Yeah, it does sound like backtracking. I think that will be the best solution because I forget how to say it, but we're like looking for possible elements that will how to say it. Actually, I forget how to say it, but like with backtracking, we actually can go through all these elements and generate all the subset and then just backtrack to each element and save the subset we generate. For example, we start from this. We're gonna generate 1, 1, 2, 1, 3. And then there is no more possible subsets. Then we're gonna backtrack. So backtracking is recursion. That could be it is the best solution for this. Is anyone have any other suggestion? Any suggestion? Let me wave to the camera. Let me wave to the camera. Any suggestion, please? Okay, we go with backtracking. Let's do it. How we can do it with backtracking? Let's say we have 1, 2, 3. 1, 2, 3. Who can explain how we can do it with backtracking? How do we even come up with the solution? Okay, everyone is quiet. It's okay. There's not so much people here. But let's see. What is backtracking? Okay, it's fine. We all learn in here. So backtracking is simply okay. Do you know recursion? So backtracking is like it is a recursion. How to say it? So let's say we did recursion this, recursion, then this, launch another recursion, then this, launch another recursion. Backtracking is when you keep like going back. So this effect is like backtrack. And like so you're looking for something inside like let's say there's a lot of possibility and you're looking for some couple of possibility. So what you do is you launch a recursion function on all the candidate, and then this recursion function is either gonna say okay, this what I'm looking for, or X, this is not what I'm looking for. And like the effect of like going back, returning ish call to others is like I think where the name of backtracking come back. So this call is waiting for this waiting for something. When it finish is backtrack to this, and this backtrack to this, and this backtrack to this. So this is the idea. It's like, just think of it just recursion. The backtracking is just the name of the algorithm. What do you think? Any thoughts? Did you get me? I don't think I explained too well. Yeah, so it is recursion, and one of the key of it is like it's backtrack when we, so let's say we're looking for this possibility that did generate 3 other possibility, right? And this generates 2 possibility, and this 2 possibility. So for example, if I go to this possibility and they come here and they find out this is doesn't validate or not valid, I don't need to check this. I will backtrack. I will backtrack to this and then go to this and continue, go to this and continue. I think thinking, I'm not sure if we did the PLD about backtracking, but we did about recursion, but I'm not sure if we did talk about backtracking. I think we did. Or deface. I think deface or something. I need to see some PLD we did talk about backtracking a lot. But think of it as a recursion. Or let's see this image. So initial state, checkpoint, not accepted, accepted. Okay, yeah. This is something like this. You generate many possibility and you stop. Once you see not accepted, you stop. You don't continue. And then until you finish, you find the one that you're looking for. In our case, we want them all, right? So we're gonna use like a recursion or backtracking, but we're gonna accept everything. How we can start it? We can try something like this. Let's put it in the middle. So how we can start this? So first let's design our backtracking. So we're gonna give backtracking, we're gonna give it this array, and we're gonna start from this number, and we're gonna launch on it the recursion function. It's gonna generate all possibility, and all this possibility we're gonna add them to the result array, including itself. And then we need to go to this part. So when we deal with this, we're gonna go to the second element, but the second element we don't wanna generate again with one. So the array is like a shrink here. Then we generate all the possibility here, and then we go to the third element, then generate all possibility here, which only one, right? Because we don't want to duplicate, right? And if we didn't check the array, if we go here, we're gonna generate 1, 1, 2, 1, 3, 1, 2, 3. This is all possibility we're gonna generate from here using this. When we're gonna go to 2, we can also generate 2 with 1. So 2, 1, 2, 2, 3, 2 itself, and 2, 1. Yeah, so 2, 1, 3. We don't want to do that. Or even like 2, 3, 1. This is also same subset, right? I believe it is a subset of an array selection of impossibly none of R. Because I noticed here when they did 1, 2, 3, they didn't do like 3, 2, 1. So it's not it should be like unique numbers. So to do that, using backtracking, we eliminate the duplicate because we can just keep starting from second one, from second element. So what we're gonna do, we're gonna start our backtracking. We're gonna give it how we're gonna design it. We're gonna give it a start, so it's gonna start from 0. So the argument is gonna be start, and we're gonna give it like we need a combination array to generate combination. So we're gonna give it start index, and we're gonna give it an array of combination. So every time we call our backtracking function, we change the start, because now when we're starting 1, we're starting from index 0. But when I go to here, I want to start from 1, so the array become like this. And when I go here, I want to start from 3. Okay, so we gonna first, the combination gonna be empty, right? Empty. So we have empty array here. We can push it to result. So we can say like result. This is our array of results. So first we're gonna launch backtracking on the array starting from 0. So the argument of the backtracking gonna be 0, and then empty combination, because we just started, right? So then the array is gonna push this combination to the result, which is what we want, right? It is right here, because at the beginning we have empty combination, and then this backtracking gonna loop on all elements in the array. So first it's gonna start with 1, and we need to generate from this 1 all the possible numbers. So we're gonna launch it to another backtracking function that will generate numbers. So we're gonna launch it with 2 and 3. So 1 gonna be in our set. So we're gonna add 1 to our combination. And 2, 3. So it's like saying we're gonna start from index 1 and we're gonna pass combination 1. Because we're starting for we're trying to generate all combination of 1. So which means it's gonna be 1, 2, 1, 3, and 1, 2, 3, I think. Yeah. So this line gonna generate all these possibilities. 1, 2, 1, 2, 1, 1. So they all start with 1. You notice that? So that's why when we add this combination here, 1, then we're gonna generate the rest. So we are looping on 1, 2, 3. So first time we're chasing 1, we're gonna launch backtracking on 1. What we're gonna do is we're gonna increase the start, and then we're gonna add this number to the combination. Combination was empty at the beginning, so it's gonna become 1, 2, 3. Then this itself is, wait, let me write it here, so you can like maybe say pseudocode. So first we said we push the backtracking, gonna push combination, or like yeah, let's push combination like a copy, because that combination we're gonna keep changing it, right? So push a copy of combination to result, and then what we did is we did loop on all elements. So now we are dealing with first loop on each element of array, starting from start index. Basically our backtracking gonna be something like gonna be like backtracking start and combination array. So this is the function of backtrack. It's gonna have combination comp. It's gonna have start. Then push copy of combination to results, right? Because we need all the elements. Then loop on each element. Let me do like this. You know, it's one case. Loop on each element of array starting from start index. Now we're looping. When we are looping one, what did we do? We add this one itself to combination. So add element to combination, and then we're gonna launch backtracking. So when we add this to the combination, we're gonna launch backtracking on the array from the start. So we're gonna do like I minus 1. As we did in the beginning, we launch backtracking on all the array because we're starting from 0. This time we wanna launch backtracking only on these 2 elements, because we are looking for combination of 1 with the rest of 2, 3. So 2, 3 here and 1. So it's gonna be backtracking. Let's see, backtracking e plus 1 and combination array, or like let's say start, or like e plus 1, because when we're gonna be looping, let's say we're gonna use index e, so it's gonna be e plus 1. So first e was 0, and then I launched backtracking. So the e here gonna be 0 plus 1. So the start with this backtracking, when you're gonna start, the start is gonna be 2. So this gonna have 2 at start. So this has start 0, start equals 0. This gonna have start equal 1. And what else? I think that's else that we did so far. Okay, let's continue and see how we're gonna generate this number. So 2, 3. Now we're gonna launch backtracking on this, right? So it's gonna do the same thing. What it's gonna do is push copy combination to result. Now we did push this right here because we were in the first backtrack call, so it did push empty array, this one. Now it's gonna push 1, so it's gonna push 1 combination 1, and it's gonna loop on each element of array. So element of array is 2 and 3, so it's gonna loop again on element 2, and basically it's gonna add to combination start, add element to combination. So combination was 1, 2, 1. It's gonna add 2 the elements that we are at, and it's gonna launch backtracking and e plus 1. Now e here was 1, or like e right here was like a 1. So it depends how we're gonna do it in the code, but let's just say the start plus 1, so it's be more easy. Start plus 1. So start 1 plus 1 is gonna be 2. So if we see start plus 1, so the next array is gonna be just 3. This backtracking that this gonna launch, it's gonna have just 3 and combination 1, 2. Then 3, this backtracking that we just launched, or this function, or this recursion, it's gonna do the same thing, right? So backtracking gonna always do the same thing that we plan inside it. What it's gonna do, it's gonna push copy of combination to results. Okay, combination we have 1 2, so it's push 1 2. If you are trying to understand and you can't or you lost, I hope when I like finish this everything, like it will make sense for you. If not, just ask question. Hopefully I can help you understand it. But basically we're like launching recursion function on each level, and each level we get new combination and we directly pushing them to the result. And here I'm just trying to display level 1, level 2, level 3, and like what's gonna be inside the variable. So we had combination variable and start. Combination is this one to the right here, and start is this number right here. Start is 2 gonna be. Now this function did start as a recursion from the previous one, and it's push copy combination to results. Here is it, and it's loop on each element of array. There's only one. It add element to combination. Okay, so this gonna add element to combination. Here is it, and then starts backtracking. So it's gonna call itself as a new combination, or like a new function. What happened? Okay, a new function with this combination. So it's gonna call, go to backtracking, it's gonna call backtracking, it's gonna give it start, right? The start, it's gonna say starts from S2 plus 1, so S plus 3. So the array we have is 0, 1, 2, so index 1, this should be index 2. 0, 1, 2, 3 is empty, so the array here is empty, or like there is nothing. So this we can use here as a condition. If the array is empty, or it is out of range, or like if it's bigger than the length, we just stop. There's nothing, right? But that's we need to do it in inside the code, so we need to like add it somewhere here. But when this backtracking was adding combination 1 to 3 to 2, when it launched backtracking on start plus 1, this value start plus 1 become 3, right? But this backtracking did start, so if it did start, it's gonna go do the same thing. So it's gonna push copy of combination to results, which is this one. So it's gonna push it to the results 1 to 3. So we can check if the length of the array is bigger than the, or like if the start is bigger than the length of the array, we can stop return, and there's no need to loop on like an empty array, right? Something like that. So here we need to do like a base, but we need to push combination first, then a base. If starts bigger than length of array, return. Now this gonna return to this, on this. When this gonna return, the combination is 1, 2, 3. This gonna return to here, the same combination is 1 2 3, and then we deal with 2. So all this line we did go, it was just this loop waiting for dealing with 2. Now it's gonna loop to the second element. Now second element, we need to combine it, or like generate the same thing we did with 2, but this time with 1 and 3. So we're gonna find like 1 and how many elements we're gonna find here? It's gonna be 1 3. So we need to find, but the problem is we have 1 that was in the beginning, but when we were dealing with 2, we did keep changing the combination, right? So the combination here did change. So it's become 1 2 3. So what we need to do here is like we need to remove these elements from combination. So when this gonna return, or this finish, I'm gonna pop last element and then return 1 2, and then this, when it's gonna finish, it's gonna pop last element, it's gonna return 1 2 1, and then this gonna have 1. So backtracking here, when it's gonna finish, pop last element, because we added here, right? So when we loop on next element, we deal with the next combination. Did they say the next combination? So the same combination. So we go to 3, we're gonna do the same. We're gonna add element to combination. So let's do it somewhere here. Do it here. So it's gonna become 1. It's gonna become 1 3. Right? What about the start? We're gonna launch backtracking, the start plus 1. So this is element, what index is this in the array? Index 2. So it's gonna be 2 plus 1 3. So maybe you shouldn't do it start, but because so it is the E, not start, because the E on the element of array. So 3, when we're gonna launch backtracking on this, we're gonna check its position plus 1. So position of this is 3, the index of the array. So it's gonna be empty array. There is no more possible element, right? So because basically we are sending backtracking to the same array, it's just that we shrink the start. Instead of starting from here, we start from here. Now the last time we 3, when we're gonna do plus 1, it's gonna be like outside of range, which means like empty array. But when we launch the backtracking, it did push copy of combination to result. So we did what we get with what we want, which is 1 3, and then if starts bigger than the length of array, return. So it is empty array, which means the start is bigger. So it's gonna backtrack, return to this right here. When it's gonna return with 1. So it's gonna pop this element, pop this, and then it's gonna return to 3 after popping this. And now that we finished this and finished this, what's gonna happen is this also gonna return to this, right? Because this all happening in backtracking. So each function is waiting for each. Now when this gonna return, it's also gonna pop something. It's gonna pop what? 1. Now we have empty array of combination, and we generate all possible 1 combination, 1 1 2 1 2 3 1 3, Now this function gonna go to the next element, which is 2, and gonna do the same thing. Let me try to put somewhere. So 2, what's gonna happen to, let's just put it here. Same as we did here. When we go to 2, we're gonna reduce this, we're gonna increase the start by 1, so we're gonna start from index 1. No, sorry. We're gonna increase the current index by 1. So it's like we're gonna focus on 2 and deal with combination of the rest elements. Like we did in 1. We said, okay, 1, and I'm gonna combine it with 2 and 3. Now we did go 2, I'm gonna say, okay, I'm gonna combine it with 3. And why I don't combine 2 with 3 and 1? Because 1 and 2, we already deal with them here, and we don't want to duplicate, because 1, 2 element is equal to 1. I don't want to duplicate. I need like unique numbers inside. So what we're gonna do here is the same thing as we did. We're gonna follow the same backtracking. We launch backtracking on this. It's push. Okay, so when we did go, no, we didn't launch backtracking on this. So we did launch backtracking on the whole array, and then we are inside the loop, which was first dealing with 1, and now we to go to the next element. So basically we are here. So add element to combination. Okay, so it's gonna add 2 to combination. It's gonna become 2. Because the combination is empty, right? Because when we were backtracking from first element, we were popping all the last element until we pop last element 1, it's become empty again. Now backtrack by e plus 1. So the start's gonna be e plus 1. E here is 1. E plus 1 is 2. So it's kind of like saying we are gonna deal with array from index 3 to the end. So only 3. Our next array that we're gonna deal with is only 3. So other way to say it is like we're gonna generate 2 with 3. So the start here is 3, is 2. Combination is 2. And this, when we launch backtrack on this, with this with this condition, like combination 2 and start 2, what it does is push copy of combination to result, which is 2. It did push it, and then if starts bigger than, so it not, start is 2, the array is 3, the length of array is 3. Loop on each element of array. We have only one element, so we're gonna loop on it and add element to combination. So let me do it here. Add element to combination, so it's gonna become 2, 3. And launch backtracking with e plus 1. So e here is 2, it's gonna become like 3. 3, it's gonna be empty array because there's no index 3. So this gonna launch a backtracking, and we're gonna add 2 plus 3. Because this backtracking gonna do the same thing again, I'm gonna push combination to results, and it's gonna push combination to result, and then it's gonna check if it starts bigger than the length of array or equal, I think. Starts bigger, greater or equal. can do like creator record the length of array. If it is, return length of array 3, and we have 3. Start is here 3, so we need to start, which means like the array is empty, so this cannot return. So that's it. When this gonna return, it's gonna pop 3, it's gonna be 2, pop last element, gonna return here to this, it's gonna also pop last element, and this gonna have empty array, and what's gonna happen is gonna go to the next element. On the next element, it's gonna do the same thing. It's gonna add element to combination, so this gonna do 3, add element to combination, and backtrack by e plus 1. E plus 1, e is 2 here, so plus 1, it's gonna become 3, so it's gonna be empty array because there is no element. So after in index 3, so when we launch backtracking, we add combination to the results right here, so it's gonna be 3 here, and because the array is empty or the start is bigger or equal to the length, it's gonna return, and this gonna return here, it's gonna pop this, and because the loop finish, this code gonna finish stop 2, and then we just gonna return the result. It is boring to explain, but hopefully it may help you visualize. Backtracking is always hard to visualize, but I hope like this it did help. Okay, who have a question? Once you understand backtracking, well, you can start passing array elements instead of appending, calling the function, then pop it. That way you don't change the array and you save online. Once you understand backtracking, instead of appending, like appending the combination. Yeah, you're right. I think when you pass the combination and you deal with it, you save a lot of space. But I also like when you just do it like array at the start and just put everything in it. Calling the function, then pop it the way done.
I don't think you understood it. Maybe see those 3 lines in your pseudocode. So add element to combination, then call backtracking, then pop the last element. Instead of doing that, you send in the combination plus that element in an array. So you don't change the combination itself. So it's almost like you concatenate a string, right?
So you create a new element, you send a new array. That's good.
Send or, for example, if you like you did e plus 1, the longer version would be e plus 1 like outside, and then you send in the backtracking, and then you remove.
Okay, your voice was cutting off a bit, but I think I understand that when we launch new backtrack with the combination array, we don't send the same. We don't need to add it here to the same combination. We can just add it inside argument, like concate.
Yeah, exactly. The way you do it with E+1.
You
send combination plus and the element between brackets.
But that will affect, I think, the space complexity or not. I'm not sure. But I think, yeah, that in that case we don't need to pop last elements. But we're probably gonna use a lot of new memory, because here we're using the same.
Honestly, it should be the same. It should be the same. You're adding the element and then you're passing it, and then you're popping. That's 2 extra like operation.
Okay, your voice is cutting off. Like
even if it's 01 still.
Okay, we can try do it in that way also when we are coding, but who did not understand, or what is the most part confusing you? Oh, saving the add and the yeah. I'm just like, so each function, I don't know, I think this space I still don't understand it well, but I will probably do some research about if they are all one. I see. I think that will optimize it. We can do it in that way when we are coding. We don't need to create we don't need to add it and then remove it. Okay, we can go to converting this to code. So I think I can split my screen. This. Okay. So what do we have here? How are we gonna go about it? So let's design the function of backtracking. So it's gonna be backtracking. We're gonna give it start and combination. Let me know, Sabah, if the way I'm coding it, it's gonna allow us to do what you suggest. I think the change gonna be just in this last 3 line. So thumbs up, okay. Let me react with thumbs up too. So so start combination, and before we design backtracking, we said we're gonna launch it with start and empty array. So let's do that. Let's launch backtracking, and we're gonna give it start. Our array is gonna start from 0, so index 0, and our combination at first is empty, right? We don't have anything. And also in the results we don't need empty, so that's every time we are in some element we push it directly. we're gonna need the results. So results or just res. What else we're gonna need? I think that's all. So backtracking, first thing we does is push copy combination to result. So it's gonna push this to result. So result append. We can do like comb dot copy. So we push just the copy of it. Because if we push the comb and then we change it somewhere down, it's gonna also change in the result because this is just reference. Other way we can do like this. Let's do copy so it's more clear. So we push copy on results like we did here, push copy to results, and we can check if start is less or is greater or equal than length of array nums. So nums right here. If it is greater, which mean we did pass the array, we're gonna return. This case is this part right here. When the array is empty, we did like pass it. Like for example, s is 3 and the length is 3, but the array is 0, 1, 2. So it needs to stop return. Just add that combination and return. Actually, we can do this inside here. It will optimize. We can look to it when we reach it. Loop on each element of array. Okay. So for loop. Now we need index and range gonna start from our start, right, and until the end of the array. So length end of array, we can do like here and equal length nums. So this is the length of array, the end. So the end is gonna be number 3, but the range function is only gonna generate from 0 to 2. So 0, 1, 2. To index as e. Now append the elements combination. Let's say we don't wanna append and pop. We can just do backtracking. And we're gonna put e plus 1. So we're gonna launch the same function of backtracking like we did here. So we're gonna launch same function, but when we gonna launch it, we did increase the number from 0 to 1, and here we increase it from 1 to 2. So every time this array is shrinking. So here is like saying, hey, don't start from 0, now start from 1. And what else we're gonna pass? Combination. But combination, we need to add to it the element we are on, right? That's why we were doing it. We can do like combination plus so combination is array. do we do list e nums e or directly nums e? I think because if we append it, okay, so we can do like this, nums e, which mean like, hey, this combination that we did here, that we pass here, now it's gonna add to it like 2, right? But when we're gonna backtrack, we don't need to remove it because each function now have its own combination. So it have its own space that have the value. So none of them use the same space. Okay, and then what else? Pop plus elements. Okay, that's all. Okay, same logic as in yes. So here each function have its space or like argument. But for the list can be crucial for space optimization. Like imagine a big array, like let's say an array that have a million elements. It will be important to, I think, to use one space. Okay, we can test the code, I believe. I think that's all. Run. Invalid syntax. Wait, let me say hi. Hi. Hello. Hope you're doing good. Okay. So invalid syntax in line 8. Let's see, line 8 for E in range. Run. Another error in, I think I call it series. Empty array. I am doing some mistake here. This append comp could be. Oh, I did not return raise because we add them to return, right? Okay. Yeah, we add them to raise, but we did not return raise, so return raise. Okay. I'm excited to see how much. 97. Hello. Wow. Wait, 97? That's crazy. Okay. Okay. So that was it. The first LeetCode. we can go to second LeetCode, but let's see who have question. Of course, code. Here is it. Who have question about the problem? LeetCode, anything? You can ask in the chat or like open mic and chat and ask. It's all fine. So the second LeetCode gonna be the optimization thing. So one of it is like this one. We don't need it actually because the for loop, if the start was bigger than the end, the for loop is not gonna enter or equal. If the start equal the end, the for loop does not enter. We can test it. So if for e in range starts, so if this was 10 and this is 10, print e, like it does not, it should be less, so like 9, then it's gonna be print 9, right? So we don't need actually that condition, we can just let it be and remove this, and if it's not, then it's gonna append and doesn't go here, then it's gonna exit. Okay, another thing is here, if start, we can use this inside here as like if the start is greater, if the start is this, we just append here and the return. There's no need to call another backtracking. You mean here? It will be true when we reach the last element as start. It end in length -1. It end in length -1. Do you mean it's never gonna enter this function? We're talking about this one, or range go from A to B -1. Yes, the range, yes. So this one is gonna go from, if the end was 3, it's gonna go from 0, 1, 2. But now, when we are in the last element, we do e plus 1. So actually here, we launch on 3 on the start. And this open another backtracking function, and then we append and we return because there is nothing in 3. Why not, before we launch backtracking, check if it is 3, which means bigger than the length of nums. Side here, print hello Sabah, like this. So if starts, which mean right there, so start +1 like this, because we don't want to launch it as start. No, sorry, e plus 1. If e plus 1 is greater or equal to this, then we append this and then we return. We append this? No, I think we append this. not this, we append this. So basically we just avoiding to call this. Oh, okay. Yeah, I think I was using wrong one. I was using start, but I should use this one. Okay, there's no need to hello Sabah, I guess. Append, we don't need to append copy, do we? I think, yeah, maybe, I'm not sure. And length. Okay. Oh my god, it's optimized really well. I think I have some error here. Invalid syntax. What? I did the remove it. What is the problem? And length of nouns. Oh, this one. I can use end. Okay, I think that was not helpful at all. I guess backtracking is better. Okay, maybe just LeetCode. Anyway, I hope you got the idea. I don't know. For me, think probably better to not call backtracking again, especially if you are using same area. Maybe it does not matter. Anyway, let's go to the second LeetCode. Let's take it to Excalibur. And example. Okay. What they are saying? They're saying given an MXN matrix, return all elements of the matrix in spiral order. So from 1 to 2 to 3, go down, go left, go up, and then go again left. Right. So 1, 2, 3, 6, 9, 8, 7, 4, 5. Okay, and then here it's gonna be 1, 2, 3, 4. Okay, I think it's easy to understand the problem, but probably not easy to do solution. What do you think? How we can solve this? Any thoughts? Oh no. Any simple solution, please? It's not how to use zip. What other solution other than zip? Wait. I think I saw someone paste the code somewhere here. I did not see it. Oh, this is for the previous LeetCode. Okay, backtracking. Okay, it's same concepts, I think, but you only pass edx. Okay, so you did use this result here and then backtrack. You also did use pop. Nice. I think it's same, almost same solution. And if it is greater than the length, you just return. Do you have any zip solution, Sabah? But maybe we do it with simple solution first. Then we can see how we can do it with zip, or like if you have some solution. One of solution can be just pointers. Just go to all through all the array and move. When I reach the end of this, I go down. When I reach the end of this, I keep going left. While matrix for x matrix. What the hell? What? So while matrix for x in the matrix appended to this. And then matrix list zip. So basically you make them all a list with some magic spell right here. I don't know what that is mean. So you can check it if it works. Yes, you can explain.
So basically, you just rotate. Yeah, clockwise. So you first of all you start, you append the first row, right? And then you flip it
you flip it
counterclockwise.
this one.
So
this one is flipped.
you remove like the second row, or before the flipping, you remove the first row, and then zip basically takes the columns and makes them rows. So in this case, in this array in particular, in this matrix in particular, 1 2 3 4, and after the zip it would be 1 5 9 2 6 10 3 7 11 4 8 12, right? But if you flip that entire thing, it would be 4 8 12 3 7 11 and 2 6 10. So basically you almost like rotated it counterclockwise. So if you shave off the first row, right, and then rotate it, you basically will have, you shave that again and rotate it, and it becomes 11 10 and 9. You rotate it and you remove it, and you keep doing that until you basically have nothing in your matrix.
Wow. I still looping my head around it. So it like first you do matrix 1. So it only deal with one at a time, right? So while matrix, and then for x in the matrix, it's gonna add all everything. Now that we add everything, we're gonna
Not really, no. It deals with everything but that.
oh yeah. So we put all the elements this one in the array, and then the second time is we zip the whole this array. Now the zip, what output does it give? Like if I do zip this, array, equals zip or array, and then print zip mat array. Let's say array. What?
Put a list around that because it will give you an object.
Okay. List. So this become 159. 159. Okay. So
takes the columns and makes them rows. Right? And when you flip the entire thing, it looks like you put everything counterclockwise.
So this gonna become 5 9 6 10 7, 11, 8, 12, and then you reverse them. So it's gonna become starts from
812
this.
is first.
12,
Yes. 7, 11, 6, 10, 5, 9.
11, and 16. Okay, I see it now. And then 5, 9. And then you add in the matrix this 8 and 8, 12, which is this part. So you did put this
I
part.
don't add it in the matrix. No. I add it in the result. But the matrix basically just removed that first row.
Okay, so there's some append to matrix here.
No, the matrix actually, it removes from it rather than add to it. You keep removing the first row. So in this case, you started with a full matrix, right? And you removed the 1, 2, 3, 4 row, right? So now in your example, you worked with it without that row. So the matrix is 1 row less than it was before.
Okay, we did remove this, right?
Yes, we removed it.
And then
with that matrix started from the second row.
okay, so in this parts of the code, we did append.
Don't remove anything.
We did append.
You just append.
So so the zip does remove the element.
You remove it with that matrix 1.
Oh.
So after zip, so you start from the second row.
Okay, so this remove. Okay, I see. So you did add them, then this gonna remove them, and because it is zip, it's gonna also flip them to something like this, and then because of this, it's gonna flip them something like this, and then you have now new array, put it in the matrix. So for next while loop, you're actually dealing with this instead of something like this. Then we just gonna loop on x, which gonna be 8, 12, and then same thing gonna happen. It's gonna be remove this, and you gonna again flip this. So this gonna become as I think original, or like, let's see. So 7, it's gonna become, so it's gonna become 7, 7, 6, 5, 11, 11, 10, 7, 6, 5, 11, 10, 9, and you're gonna reverse them with this. Then it's gonna become 11, 10, 9, and 7, 6, 5. Basically the reverse is like flipping this before this. And then when you're gonna go to the while loop, you're gonna loop on this, which kinda what we want. Like we're gonna push 11, 10, 9. That's genius. And then we're gonna remove this. Now we are have only this part right here. Yeah, we did add it, and now this zip gonna remove it, and it's gonna what does it gonna do to this? I don't think it's gonna do anything. I think it's just gonna reverse it because it's one line. Yeah.
It's gonna do the same thing. It's gonna be 7 on its own, 5 on it, 6 on its own, and then 5 on its own. It's gonna shave off. It's gonna flip it. So 5 first, shave off 5, and then
5, 6. Isn't it gonna add them? Oh, it's gonna split them.
Yeah.
Okay, and
So it's gonna be one array of 5, one array of 6, one array of 7.
Wow, it's actually amazing. It's good. What other solution? I mean, the idea is genius. Genius. 88, nice. What could be other solution? If you wanna do it maybe with pointer, it's possible with pointer too. The boring solution. Let's use this one because it's short. Let's use this one because it have many. Okay, what we can do? One of the solution is like define for pointer, like pointer here, like because let's imagine we're gonna go like this, and then I need something to tell me, hey, I am reached the end. Okay, and then I'm gonna start going. Oh, you did reach the end. Go going. You did reach the end. Keep going up. Oh, you did reach the end. Go right. Oh, you did reach the end. You finish. So something to point here. It's can be like left pointer, right pointer, top pointer, bottom pointer, and through this pointer I'm gonna keep moving through this array. So I'm gonna start here, add this, add this, add this to the array, and then I'm gonna see right pointer. What you can do here to know if like the right. So I need something to tell me that I need to finish. I guess when I reach to the right pointer, I stop. Then when I stop, I'm gonna need to go down. So I'm gonna increase the tip pointer by 1. So tip pointer gonna be here. So I am still in same coordination, but I'm looping an array. But when I reach here, I'm gonna increase t. So this time I'm gonna reach to this element, and then I need somehow to go down to this element. Is this gonna work? So if imagine it's like a for loop, looping. Then I reach this. Then I increase direction, yeah. Then I increase the top by 1. Then I keep looping like 8. And then I increase it. Do we increase? I think we can, because I did go to 8 and I know I'm in the right element. When I'm in the right element, I need to keep going to 12. How I can go from here to here? I need to increase t, but I don't want to increase t because I didn't finish with this row. We can do something here. So we have top. So if we say 0, 0, 1, 2, 0, 1, 2, 3. So top is 1. And we are in 8. Bottom is 2. think. So what if we loop from think with me. Pamparam pamparam. Okay, what we can do is just when we reach the right maximum, we just gonna create another loop. What it's gonna do is gonna loop through the last element of right, because when we reach right, we know that we're gonna need to add this, so we're just gonna add this, and so we're gonna loop on, and then we're gonna add this, so we're gonna loop on from the top to the bottom, which means we have two levels, so we're gonna loop twice. The first time we're gonna access this, right, and then it's gonna loop again, and then we're gonna have this element. It's like doing like length -1. Yeah, so but we don't want to go 4 to 4. So e of this gonna be 2, and this can 1. So I'm gonna do matrix index 1, which is gonna give me access to this. Then I'm gonna go directly to the last element and add it to the array, and then it's gonna go to the next loop, because I'm looping on this to array, and it's gonna go to the last element and add it to the array. Let me see if I can write something to make it clear. So first loop we did L left equals 0. We did the right length of what they call it, matrix. Length of matrix. -1. Then we have top equals 0. Then we have bottom. The bottom is also length of what? Bottom. I guess length of matrix. -1. I think this one is wrong. So the right should be either like index 0 or 1 or whatever. So to know how the maximum right, I need to cancel this 1, 2, 3, 4, right? So I need to go inside the array, for example, index 0, and see how much length of it. And for length on B, I need to do matrix, length of the matrix, which means the length of all the elements inside the matrix -1, because if there is 1, 2, 3, -1, it means index 2 is the last element. So when let's do this part, like this part where we're gonna loop on the first one. So starts from first element. Loop to the right until you reach right pointer. I guess That's right. So we're gonna loop until the right pointer, like loop until error. Add element to the result. When we're gonna finish that, we're gonna increment what we're gonna increment. If we add all of this, something needs to change is the top. So that we need to go down. So the top gonna be +1. So we did add this. We stop here because it's like our loop. We say gonna loop from 0 to error. So it's go looping until error, or like loop from L until error. If we're using range, probably should do error +1, but yeah, it makes sense now, right? Like this. Now we add all the elements here. Now we need to go down, but if we think of it like this, it can be complicated. What we actually need to do is just to loop on this to array, which means looping on this to right here. So we're gonna loop twice, and first time we're gonna access this element, and second one we're gonna access this element. So both of them we're gonna access the last element. So loop on. Now we did increase top +1, so it's gonna automatically skip this, the first one. So we can use it loop from top to the bottom, right? To bottom. So we have bottom here, we have top here, which means 2. So top gonna be 1, bottom gonna be 2. So 1, and we're probably gonna use range, gonna do like 2 + 1, which means it's gonna generate numbers from 1 to 2. And I'm gonna use this to access the array and then reach to the last element. Now when we're gonna reach to the last element, we need to keep going like this, left side. But let's add this here. Loop from top to bottom. Append element, right? Append element to result. Then we said we're gonna do so when we're gonna append this, we can finish with this. Now it doesn't make sense to R to be pointing on this element. Right should move here, right? Now this is our array, our new array. Let's have top, bottom, left, right. So right -1. Okay. What else we did or should do? Now that we are here, we need to go from here, right here. So we can reverse this and in the loop, so we can loop on this element, and but we need to skip on this, skip this. So just give me a second. Back. So how we can do this? So so we are, if we think about it, So we are in 5 and 9, so we are dealing with this too. And so we are using top. How we can add this and this and this. So we have right here. So we have access to this and the bottom. But do we know that we are in the bottom? Yeah, because when we're gonna go down here, we're gonna keep going until we reach the bottom. So I guess this next step is gonna be always at the bottom. So we don't need to care. So we are here, we have the bottom. And we have the right. So we can go here and then move to here. So if we're gonna move to here, we need to use left. So I guess the bottom doesn't matter. I can just use the last element. Yeah, I can. Okay, so when we reach here to the end, we actually don't need to think about like how to. We don't need to think about the how to access the last element. I know it is this B. So I will just use B to access last element that I am on, because B might get increased. Maybe I'm not sure, but let's see. So we know that when we did go down like this, we reached the bottom. So the bottom is this. I have access with them. If I did matrix B, if I did matrix index B, I'm for sure I enter this. And now I will just use R and left to for loop on this. And then I need to for loop from 11, 10, 9. So I'm going to just reverse it. For example, in for loop, I can loop in reverse. So what we're going to do here is, let's just write what I said. We said we're going to access, or like loop on last element on the bottom. Loop, or like let's say select last row, loop from right to left, which means it's reverse. Add append element to result. What else? When I do this, what you should do, if I append this and this and this, that means I done with this. That means bottom should go up, right? So the new bottom gonna be here. So bottom or B plus 1 or bottom minus 1. We call it B, but it's okay. Yeah, left, right, top, bottom. So bottom minus 1. Now our array is this part. 5, 6, 7. We have right, we have left, we have top and bottom, which mean we have one row. I still don't know what this select row mean, because okay, so by select row we mean we're gonna always access matrix. So matrix is mean matrix B, which mean when I'm for looping on left to right of the matrix B, or like when I'm appending the element. To results, I'm appending matrix B and using the left and right and using the E of the for loop to get the coordination. For example, if I'm looping on this element and the for loop I give it R and L, it's gonna give me here what? It's gonna give me it's gonna give me so matrix E. Yeah, so it's gonna give me E here. What is gonna be? It's gonna be 2, because we are looping from left to right, and we're gonna do right is 2, right minus 1 is 1, and wait, so right here is 2, so 0 1, yeah that, so 2, so the range gonna loop from 0 1 2. Okay, so maybe I need to do right plus 1, so it generates number 2. Then that number 2 I can access to 11 and add it. I think we can see this when we're coding, but in general it's like loop from right to left on the bottom row. What else? Then we said we're gonna change the bottom minus 1, so now we have a new array. Now what we're gonna do, so we need to again loop on this until the right. How are we gonna do this? Five. That's how I'm gonna get access to 5. How do I know? Think with me. So I need this. But when I go from here to here, oh, there is a problem here, because I don't need to go here. Actually, we need to go like we did here. We need to go down to the end, because what if we have matrix of 4 like this? I actually need to go like this, like this, like this, like this. Like, notice I did not go here. I did go up, then I go here, then I go down. So when we reach the bottom, always from the bottom we go max to the top, where we have the top. Or I guess here gonna be this is the top, right? Because we deal with this. So the top become here. So we're gonna keep going until the top. So after we finish with this, here we're gonna go up until the top. Okay. How we gonna do that? How we can go until the top and add all the elements? So select the bottom. After it, let's say we are going up as a comment. We are going up. This one is going down. This one is going left, bottom. We are going up. Loop. How can go up? If we see the array going up, mean we need to go take 9. No, not 9. So we need to start from bottom, because bottom here. So, and bottom here is pointing on this. So we're gonna start from bottom. We're gonna take this number. Let's say, for example, there is another one here, and this is the bottom. This is that we finished the bottom, and now we're going up to go 9 5. So we're just gonna select this part, this part. So we have the top. So the top gonna allow us to insert certain arrays, and the bottom gonna allow us to insert certain arrays here. And we're just gonna loop on this, take the first number, loop again on this, take the first number, and we're gonna use T and B as a way to insert, because this is insert because we scratch it, right, like the last array. I hope it makes sense. Oh, I need to go back a lot. But basically, we're gonna use T and B to select which arrays we're gonna loop through, and we're just gonna take their first number. We probably should do it with zip. We will be finished right now. Okay, so here we said what we're gonna do is loop from bottom to top, but we need to select what? In this case we don't need to select anything, right? Because the selection gonna be the index from the bottom to the top, from bottom to top. So again, I'm gonna loop on this array, and then I'm gonna loop on this array, and then I'm gonna append first element of array, or first element, which is left, right? Left. Append left to the array to rest, and here append element to rest. Basically here or here we're appending the last element, which is here. Append element, we can say right, because all these elements are in the right pointer. Loop from B to the top, append left element to rest. So when I'm going up, I'm gonna append this left, and then I go up again, I'm gonna append this left, and after it, after I reach to here, I don't wanna I don't wanna like change. I only think we need to remove this, right? Because when we're gonna go to the top, that means we dealt with this. So the new array gonna be, or new matrix gonna be like this, right? So the left gonna go inside, left gonna become here. So left plus 1. Left plus 1. And when the left plus 1, that's when we have this array left. Now it's like we're gonna start again. It's like a new array. So when we deal with this all the way, which means we have a new array, then what we're gonna do is we just like gonna repeat everything we did here. So we can put this inside a while loop, that's gonna keep repeating process. So think of it like this. So we have this, 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 this. So think of this, our code, what it's gonna do is gonna go like this, this, this. Okay. It did everything here. And then the next loop, it's gonna be on this part. It's same logic. Gonna go this, 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 this. So we did enter all of it. Right? And then the next loop is gonna be on this part. Now when it is one element, is our logic gonna work? So this is gonna be like a while loop. While some certain condition x, we're gonna do start from the first element, loop from left, we have right, and we have top, we have bottom. Okay. Okay, let's see if this can actually work on this. Okay, so start from first element. Here we go. Loop from left until right. Okay, I'm going to right. Okay, I'm looping through them, and wherever I'm going through them, I add element to the result. But which element is gonna be E? So here it's gonna be the E, right? E of the for loop, and then top plus one. When I reach here, top plus one, which means this top gonna go down. Then it's gonna enter this loop from top to bottom. So top to bottom, which means I'm gonna loop on this array now. This is my new array, right? And append the right to result. Right is this, so I'm gonna access a right of this so I'm gonna loop on these four arrays, right? So the first loop, first iteration, I am here. I'm gonna append the right to result. Right is here, so I'm gonna append this, and then it's gonna loop again second time, right? Because we still have three. It's gonna append again this, and then it's gonna append this, and then it's gonna reach to the bottom where the loop gonna stop, and it's gonna append this, and then we're gonna do right minus one. So right gonna go like this, right? So basically we dealt with this, okay? And now we're gonna do another select last row b1. I did just say loop from right to left. Oh, okay, loop from right to left on matrix B. So let me do this. So on the matrix B, so I'm gonna if this is my matrix and I go index B, that's when I'm accessing the last bottom row, right? Now I'm gonna loop on all elements in bottom row, but I need to start on reverse. So we need to mention it here. Loop on reverse. From right to left. I mean from right to left, it's meaning reverse. So then we need to mention. So we're gonna loop from right to left. So in this direction, and append element to raise. Okay, element it mean E, so this gonna be, we're gonna be accessing the matrix element, so matrix B and E. So it give us the coordination of it. Okay, we did loop until the end. Okay, we add all of this. What now? We're gonna do bottom -1, which mean the bottom gonna go -1, which is gonna go up like that. Which mean our new array now is this. Loop from right to left on matrix B. Oh, we just did that one. Loop from bottom to top. So I'm gonna loop from bottom to top. Again, some certain reverse here. So I have this tree array, first one. So I'm gonna start from the third one, then go to second, then go to the first. And while I'm doing that, append the left element to the result. Left element, which means the first element. So I'm gonna loop on this, append this. Second loop iteration gonna append this, and the last iteration gonna append this. So we did append everything. Now the loop finish, but the while loop. Wait, we forgot left. So left gonna be like here. When we finish this, left's gonna be here, which mean if you notice, it's actually moving to the new array, right? Left and R and T and B. Now the while X, it's gonna keep going, so it's gonna loop again. It's gonna do the same. It's gonna go like this, like this, like this, like this. So when it did deal with this row, what happened is T become here. When it did deal with this row, what happened is R become here. And then we deal with this row, B become here. And when it deal with this row, L become here. So we can see if L and R equal each other, and if T and B equal each other, we know that there is only one element, but is it gonna work here or need some modification? So we need to add this and like stop. So our loop, we can say we can okay, what I'm looking for, I'm looking for condition to add here, but let's not see the condition. Let's just see, now we have this element we need to add, or like we did go to the next while loop, which we enter everything this in the array. Now let's say the condition is correct and let's enter this. Now is this code inside gonna work for it? So, or we just append this and exit the loop. But I'm sure maybe there is some edge case where maybe there's two. Yeah, maybe there's two, like this two. So this is just lucky that I have 5 elements. I think if we have 6 elements here, let's try it. 1, 2, 3, 4. So now we have 6 column. Let's say we have like 5. So here it's gonna be like this, like this, like this, like this, then another one like, oh no, the same, so it's gonna be another one here. Yeah, we're gonna end up with 2. So I can just exit the loop and append that last element with coordination of LR. So in this case, it's gonna be R here. It's gonna be R. And this gonna be L. And T and B gonna be equal each other. So either the loop equal or not. I mean, I can add condition if L and R equal each other and T and B equal each other. I just add this value and exit the while loop. But let's process this one right here. Now our new array is this. So when you're gonna go to the while loop, let's see what's gonna happen. So start from first element. Okay, here is it. Loop from left until right. Okay, I am looping from left until right. Okay, I add element this, I add element this. I did top plus 1. Top plus 1. Oh, top plus 1 is gonna stop the array. Let's stop while loop. So here is it. This is the condition. When the top and bottom, when the top, oh sorry, top plus 1 is gonna go down, right? So it's gonna be like this. So when the top become greater than the bottom, it's gonna stop the while loop. And I believe this is gonna be the same for right? It's gonna be that left, maybe. So when the right exceed the left, we need to stop. But when we do right plus 1, do we do right plus 1 somewhere? I mean minus 1, right minus 1, because it's going left. So this way. Okay, when this could be possible, that's when we go down and we go right. Can right become more great than the left? I think it's possible. Yeah, I think in case we have just like this, because we're gonna do left, add it, we're gonna go down. Okay, so we have left, right, we have top and bottom. Now we go through the list loop. Start from this. Okay, here we go. We go boom boom. We add this. Then top gonna become then top plus 1. So top gonna become here, right? And then we loop from the top to bottom, which is the same element here. Add right to result. Okay, we add this to result. What else? Right minus 1. So right minus 1 is here. This is gonna be our right. Okay. Loop from right to left, right to left on matrix B. Okay, it's gonna access this one. Append element to results. Okay, we append it to results. Bottom minus 1 is gonna become here, bottom. So it's gonna stop the loop. So this is not the case. I'm not sure where is the case gonna be, like if right's gonna close. Maybe it's never gonna happen. Or maybe when lefts cross the right. You can see left plus here. Where this case there's a left plus. We go from top. So left plus is when we go up. So what if, but how that can be the edge case for that? When it's possible that left can cross right? I don't think it's possible. but yeah, it's possible because this is the end. So when we're gonna go on up, and then loop from B to top, loop from B to top, append left elements, appending, and then left plus 1. Oh, left plus 1. Oh, left plus 1. So what can be this? I think this case right here. Okay, so left, right, top, bottom. Yeah, I think this case maybe. Oh yes, it is. It is this case. Yeah, in this case we will have to do this check of the left and right. So if we apply this right here, it's gonna be start from left to the from first element, loop from start from first element. Okay, here is it. I started append it, or like loop from left until right. Okay, here is it. Add element to results. Okay, add them all. What to do now? Do top plus 1. Okay, move top plus 1 here. What else? Loop from top to bottom. Okay, now my array is this. I'm gonna loop from top to bottom, so I'm gonna loop on first array and second array. So first array, what I'm gonna do? Append right to results. Right is this, so I'm gonna append it to results. As I append this, I loop again to second array. I append this to results. Then right minus 1. Then right minus 1. Okay. Now loop from right to L on matrix B. So matrix B is this part right here. Access last element and then loop on right to L. Now I have just one element, so it's gonna access it. You're gonna append element to result. There is it. We append it. Then bottom minus 1. So bottom minus 1 gonna be equal T. And what's now? Loop from right to I did this. Oh yeah, bottom minus, I did this, bottom minus 1. Now loop from B to top. So from B to top, so it's gonna access this element. Append left element to result. Append it. Then left plus 1. Left plus 1 gonna be left, gonna move here. Now here I want the while loop to stop. Okay, so we said when top so as while as long top, or like b greater or equal to top, and right is greater or equal to left. Yeah, so as long as this condition keep looping. Now we found out the condition. I think it will work. Pum 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 pum. We can try to code it and see if we're missing something. Let's work. Okay, who did understand? Hope you guys didn't sleep. It was a while to understand this. Okay, if someone have question, please go ahead. Okay, I can try to call it quickly so I don't make you sleep. Okay, so what we have here is, you know what, let's copy this and try to code it here directly. So we have left, right, top, bottom, and we said like while as, so we can do like this while b greater than t and r greater than l. While this, what we can do is start from the first element. So basically it's going to be a loop. Okay. Do it like this. So in this loop, so we're going to do for e, loop from left until r. So from left in range left, I guess we call it L, and left until right. Now are we gonna do right plus 1 or not? So range we have to do plus 1 because we did not set minus 1. So when you're dealing with the second part, you need to do plus 1, because if let's say the right is 3, you need to if you want this to count from 0 to 3, you need to write 0 4, because it doesn't include that number. Okay, add element to result. How can do that? We don't have a result, so result, add that element to result. How we can do that? Append the result. Append. What we're gonna append? We're gonna append the element, this one, the first element. And do I have coordination? Yes, it is L, and no, it's not L, it is top. So this element is in the top and L. Right, is it top and L? No, top and E. So we are looping like this. So we have L, and we have R, and we have top. So all these elements gonna be in the top. So I can do like matrix top, okay, but which one of them? It's gonna be E, because each time we move to next element, E is changing between left and right. After that, we're gonna do top plus 1. How are we gonna do top plus 1? So top is a number, so we're gonna do top plus 1. We call it t, so t plus 1. And then loop from top to bottom for, again, E in range, and this time we're gonna go from top until the bottom, so b plus 1. What we're gonna do, append result, append. This time we're gonna append the right to result. So this time I am looping on this part of array. So first row, second row, third row, fourth row. but every time I visit each row, I actually don't care about anything, just this part. So matrix E. So matrix E, so every time I loop, I access new row, but when I append just last element. So I can do -1. No, I can't. If I did -1, that means when we're gonna go to the sub array or like inside this part, it's gonna still give me this part. So I need to keep track with right air. So I need to keep adding using air, because air is moving. Every time I cut this part, I move air here. So I know where I am. Then I'm gonna do, wait, is it right? So we're moving like this. I'm adding, yeah, by right, yeah. And then when I finish, I do move right to this side. So right -1. So air equal -1. Okay, this is good. Now here, what you're gonna do here is loop again for E in range. From right to left. Now it's like we need to reverse the array, because we want to go from 11, 10 to 9. 11, 10, 9. So we can do right and then left. Okay, left. Okay, let's test it. If I did for E, in range, and I did right. Let's call right, in our case right's gonna be what? 2 1 0, right? So 2 and then 2 1. If I did this, print E, that's gonna work because the right is bigger, so I need to add -1, so it's like reverse 2. Now if I did 5 4 3 2, so it's going in reverse, right? Because I did this -1 here, but it's stopping in 2. I actually want to stop on 1, so I need to do -1, because this right here is always tricky. So I want, L is on 0, right? So I need to mention 0. So if I write 0, L 0, notice it does not go to 0. So I need to do -1. So whatever it is, -1 here. So it go from 5 to actually 0. Then I'll be able to go to 11, 10, 9. So in our case, it is in 2. So air is 2, so I have access to 1 and 0, and the loop finish. So we're gonna do the same thing here. This is our air, this is our L, and -1. Now we have access to 11 and 10 and 9, and we're just gonna add them. Append element to result. So again, it's gonna be result append matrix, it should be bottom. So we are, when we did go down, we did go until the bottom, so we're gonna stay in the bottom. So this we can access with B, so I access the last B, and yeah, and someone may say, wait, it not gonna count 12 because I'm starting from air, and air is here. And because air is here, it's gonna start from here. So here's it, we append to result, then we're gonna do bottom -1. So B -1. Then loop from B to top. Loop from B to top. What do I mean by that? Oh, going up. So loop from B to top, because now we did finish this row. We need to go up. So loop from B. By the way, we did increase B. So B, for example, is here. Gonna loop from B to top. Again, it's same as when we're going down. We're going down. We're just gonna loop on this, erase, and access the first element. So this is the same code here. Let's just write it. For E in range. It's not the same code because we need to reverse it actually. Because we need to start. Now we're gonna start from bottom B, and we're gonna go to top -1 like we did when we go in reverse. So because now we're gonna start on reverse, and then minus now to know, hey, I'm going from B to top, and then I'm gonna append results, append, and I'm gonna append left element to result. Left element to result. So I can access left elements, but let's access the matrix. Matrix gonna be E, right? Because I am moving, and each row is E, right? So E, I'm moving in rows, and now each row I want something from it. I just want the first element. But if I did 0 directly, it's gonna be the same problem because this array can shrink, so I need to use left as pointer. And then after I finish, I just put left +1 and left +1 or plus equal 1. Okay, so this is the while loop. It's gonna keep looping, and then we're gonna return a result. Okay, let's see if it's gonna work. Please, if you have any question, let me know. If you guys didn't sleep. So I have some error here. What is return type result list of int type error is not valid value for the expected return type. So some numbers did get added in array, some of them. What? I think I have some append mistake here. Oh, this one. I append B, all of it. No. We should append B using E. So only the element. not the whole array. Okay, run. Okay, what expected. So for some reason it did 6. Output 6. Where did you get 6? 1, 2, 3, 4, 5, 8, 12, 11, 10, 9, then 5, then 6, 7. It keep going. Why? Oh, it did left, it did the right -1 here. Wait, no. What are we missing? Okay, let me see. Okay, your code is kind of the same. Do you notice something I am missing? 4, 4, 4. What we are missing here? Let's do this case that our code failed. Let's see what's gonna show us. I mean, the same case, it's just that our code did not give the same results. For some reason it's add 6. I don't know where that 6 comes from. Let's do print maybe. So print, or so it did append it. You have greater in the while she did. Oh, maybe I should not enter. But we need to enter, right? Because sometimes we have. I think she did use or. Did she use or? Did she end? Why? Maybe the way she calculates error and the top. Yeah, she did not use the -1 because I did -1 here. But something I notice here is this: if not lift break. What does mean? I didn't do this. If not lift less than right and top less than bottom. Watch it. What age case this one? Break. Why we don't need to break? So if I'm going like this, it's break before, so it did go to loop, so it did go like this, and then it did go like this, and then it did some check, and if this check is valid, then we go like this. Oh, wait, I think, what that mean? If we have like, we go like this, and we go like this. What the case where I can't go left here is when I have to like this. So I go left, I go right, or maybe when I have only one row. So I go left, then I'm in the bottom, then I go down, I keep going down, then I can't go left. So when left is equal right, okay. Okay. Mm. So the left and the right should be, so it's like I will never go left if left is not less than right. So for me to go this direction, left should be still here somewhere. And for me to go up, the right should be good. So I need to add this here. It's saying to go from left. So here I'm gonna do if. Which direction is this? Right to left. Look from right to left. Mm, 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 mm. What did you say? Thinking. I have no idea. Okay, let's just simulation of the code. I think we will find out what was wrong. So this is our array. I guess we need to learn how to debug. Let's debug this code. Let's see why it's not working. What could be wrong? Okay, now the mission is to find out what is wrong with our case. We have a hint. The hint is that we need some certain coordination here. But why? I do not know. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what we do, we're gonna go for L to R. So from here, we append everything until we reach to R, and then L, and then top, and then bottom. Okay. So we did append everything, then we did top plus 1. So this gonna be go down. Then we did this one. We should append this part. So I did append this and did append this. It looped twice. Okay, so then minus 1. Then minus 1 of R. Now we have this array. It did go here. We did 4e in range. So basically it did go through this. And it appended. Let me see where is the error happen. Keep it close to us, just we know which is. So the error happened in the last iteration. Let's see what happened in that last iteration. Okay, so far we have correct 1, 2, 3, 4, 8, 12, 12, 11. Wait, did I write this in the... Yeah, it's this 1 2 3 4 8 12 11. 11 is here. 8 12 11 10. So our code is working fine here. It reached until 9. It's fine. Then it did go to 9 5. It's add 5, right? And now it did stop here, the first while loop. Now the second while loop, it's enter. It's add this, it's add this. Left become right here, R become right here, and B become right here. Now what happened is something wrong here. Let's see. So normally it should add 6 7. It add them, but somehow it go back and add 6. Like maybe it loop again, it add 6. Okay, let's see. So let's see this in the code. So this loop for E range, so it's gonna go to 6 and 7. It's gonna add them together, and it's gonna do t plus 1, t plus 1, which means this t right here, it's gonna go to the top. No, sorry, it's gonna go to the bottom, t plus 1. Now it's gonna go to the second loop. It's not gonna enter it because t is greater than the bottom, which means this for loop is not gonna enter, right? So in the range, if you give a range of loop between 5 and 1, it's not gonna enter because this is not gonna generate anything unless you did like -1. So it doesn't enter here, which is good. And then it's go to this part, and it's do for E in range of a, oh, so this is what it's at, I think. Oh, so we need to break the loop. That's why we need to break the loop, because we finish here when we add 6 and 7. And okay, when we add 6 and 7 here, top become +1. So if the top is not equal, just break. But let's see how it calls to add 6, and why it adds 6 not 7. Why did it stop there? Let's see what happened. So for E in range between right and left -1. So basically we're saying right, which is index 2, and L -1, which is 1, -1, which is 0, and -1. So this range gonna generate number between what? 2 and 0. It's gonna generate number 0. No, it's gonna generate number 1. So at first it's gonna generate 2. Then it's gonna generate 1. And it's gonna stop. So is that correct? R is R is 0 1 2 2, and L is 1. So 2 1 -1 is 0. So 2 and 1 -1 is 0. It's gonna generate 2 and 1. Okay, 2 and 1. So the first iteration matrix B, which is this one, index 2, which is 0 1 2. It should be 7. Why it not 7? Okay, let's add the print here. print this element. Line 16. Oh. So it's 11, 10, 9, 6. Six. Okay. So it does add 6, which not supposed to do that. But isn't it supposed to add 7 because it starts from the back? Okay, I can see maybe the index. Matrix B minus BE. It is 6. Okay, let's print in this. Print. Give me the value of R and L. Print. So the value of it is 1, 1. 1, 1. 1, 1. So R is also 1. Oh, we did. Oh my god, yeah, it's my bad. So it doesn't enter the for loop, but there is this R minus 1. Okay, now we can see the why it's 1, 1. So there is R minus 1 here. So actually R is here. R is here. So basically we did go at 6, 7, but it continue. It should not continue here. When we did all the number of array, we need to stop. This should not go. So here we have R equal L, and here we have T greater than B. So the last element is 6. So basically it's go here and it's added. That's why we have 6 here. So yeah, we need some certain condition here. So the condition for this, so what's the mission of this? What's the goal? The goal of this is to add the bottom from right to left. If we're gonna add bottom from our, what will be the condition? So one of the condition they use here is this. Try to understand it. They did if not, if left, if right is great. In my case, can be I think equal because that's what we did also in the. But maybe not because the way she's calculating the right and left is not as mine. So in our case, if the right and left are it was like this, and then T become like this, and then become like this. Because if they are equal, I still wanna. Okay, but maybe the B. So when the top exceed the bottom, I should stop. So this is the condition. Top. Why I did stop it? Not because L and right. It's okay if they are together. It doesn't matter for me in this case. So top and bottom. So what I'm gonna do If not, the one you said, if not, if the bottom not greater than 2 or equal, yes, this one, and then and the right should be equal or great. Yeah, I think this one gonna work. So we can do it here. Return or break. Oh yes, uppercase, you're right. Ooh, finally. Really? Just 40? Come on, let me see green. Oh, 69? Come on, not again. Come on. Universe is playing with me. Okay, I will take it. No worry. Okay. Oh my god, 10 p.m. I actually lost my I lost track of time. But it was interesting problem. I hope you guys understand it, or like if you have any question, please let me know. I can explain it. Let me paste the code. So Minotaur, don't beat me up. Here is the code, Minotaur. Drive safe, please. Okay, that was it. Okay, oh no, we have another LeetCode. Do we do it? No way, it's like 10 p.m. probably. Okay, we're gonna leave it. I don't know, I was gonna start with this one. Okay, I guess, do we do it tomorrow? We can like add an extra session to do it. Okay, how many we have to do? We did this. So what we did this one, we did this, no, this one not yet. We did this with this. So we have three. Okay, we have to this. Oh, this is 2, not 3. Wait. Click interview, where is it? Click interview. Start reading. Step by step practice. Week 10, I believe we are. So we did this one. This one we did replace it with the. We did it last week. So what happened is we did take this one right here and we replace it with this. So we did this one. This one is not yet. Okay, so we're gonna have to do this one. We did this one. We did this one. This one. Now we still have 5. Okay, so we can add this here, and we do 3 Saturday and 3 Sunday. Okay, if someone wanna do them, please just jump. I know someone in Sunday gonna do 2, so I'm gonna do 1, and then this Saturday we could do 3 of them, just to keep track. And then we have 4 more weeks. So this 2 week it's gonna be really busy. So maybe we stop here in Sunday, and after this 2 week we continue this 2. I don't know, it depends, because this is gonna be our final project, and I already subscribed to some other stuff. If we could do it, we do it. If we couldn't, we can just push it like 2 weeks after, and then we continue. Or at least we can do one LeetCode day, because there's too many. So we can do like at least one LeetCode, or it depends, and then like just 1 hour. I think we do that. We don't want like the blood to slow down, so we can do at least one LeetCode, keep going, one LeetCode until we finish them. It's better than just stop. Yeah, that was it. Thank you for being here. Thank you for watching this recording. Have a good night. Bye. Bye.